Good morning, guys. So for today's lesson, we're going to look at rate of change, and basically we're going to be calculating rate of change from graphs. So rate of change is basically the slope of that section of a graph. Okay, so we have seen that a graph is a powerful tool for showing a relationship between two variables or the trend of some measurement over time. So if I'm looking at a graph, I need to know by looking at the graph, is the graph growing fast? Is the graph decreasing fast? Is the graph slowly increasing? What's happening with my graph? Do I have a change? Do I have a constant rate of change? Or is my rate of change changing? So in this case, if I have a linear graph, a linear graph tells me that I have a constant rate of change. Okay, so that means I have a constant change as I'm going up or I'm going down the graph. So in this case, if I'm looking at my rate of change, or in any case, when you're looking at a rate of change, you're going to take 2 points on the graph, and then you're going to do the y2 minus y1. So if you remember from before, that the rate of change is the same thing as a slope, where you're going to do y2 minus y1 over x2 minus x1. And this is how I can find the rate of change. Now, in a linear function, it doesn't matter what 2 points I pick, I'm going to get the same rate of change because I have a constant rate of change for a linear function. However, for any other type of functions, there's no constant rate of change. So let's say if I have a parabola that looks like this, it's not a constant rate of change. If I have an exponential function, there's no constant rate of change. If I have whatever kind of function, it's not. The only one that has a constant rate of function is the linear one. Okay, and to find the constant rate of to find the rate of change, what you need to do, you need to pick 2 clear points on the graph, and then you're going to have to calculate the rate of change. So if I'm looking at the blue graph here, to calculate the to calculate the rate of change, so I can pick my first point here, which is 0, 400, and I can pick. I'm going to pick this one. It's not going to be very, very clear. Maybe this point here. All right, which is 5,700. All right, so this point here, it's going to be 5,700, and this point here, it's going to be 0, 400. Okay, so what we're going to do here, we're going to call this x2, y2, and this x1, y1. Okay, and then I'm going to use this formula, y2 minus y1 over x2 minus x1, and that's going to be 700 minus 400 divided by 5,000 minus 0, and that's going to be my rate of change. Okay, and the rate of change here, it's going to be because that's going to be, that looks like salary and the sales. So it's going to be, the rate of change is going to be salary versus the sales, the commission. All right. So this is basically doing the rate of change for the blue graph. Now for the red graph, you're going to do exactly the same thing, but we're going to pick 2 different points. So we're going to pick, like, let's say these 2 points, and then you're going to do the slope or the rate of change. Okay. So now let's look at, I'm just going to go to the next page. All right, so in the science experiment, the temperature of a solution is measured during a reaction. The relationship is showing in the following graph. We can see that over the first 10 minutes, the temperature increases uniformly from 20 degrees to 100 degrees. So what we're seeing here, we're seeing basically, if I'm looking at this here, this part of the graph from here to here, we see that it's increasing. We're increasing sharply and uniformly from 20 degrees to 100 degrees. Then what do we see? We see a constant temperature, right? So the temperature stays constant 100 degrees. And then we see a decrease in temperature, but then this decrease is not constant. We see that it's kind of like a curvy decrease. So in the rate of change here, it is not constant in this part. Okay. Here, between 20 and 100 degrees, so for the first 10 minutes, almost, we have a constant rate of change. And then if I'm looking at this part right here, this is, I have a 0 rate of change. So my rate of change here is 0 because I have no change in temperature, right? So my Y2 minus Y1, I have no change. It was 100 and it stayed 100. So 100 minus 100, that's a 0. So I have 0 rate of change when I have a horizontal line, okay? So if I'm looking at the rate of change for the first 10 minutes, let's say, or almost 10 minutes, what we can do, we're gonna do Y2 minus Y1. So let me erase all of this. And then we're gonna look at these 2 points. And then for this point here is 10, 100. And this point here is 0, 20. And then this is x2, y2, x1, y1. And then we're going to do y2 minus y1 over x2 minus x1. And then it's 8 degrees per minute. So we have a constant change of 8 degrees per minute. Okay. Now between 10 and 20, they're asking you here, what's the rate of change between 10 and 20 minutes? We said that because there's no change in temperature, the rate of change is going to be 0. All right. Now, after 20 minutes, the graph is nonlinear. This indicates that the rate of change is not constant, as I said earlier. So from the graph, it appears as though the temperature decreases faster initially, then more slowly as time passes. If we approximate the curve by a straight line, we can estimate the rate of change at any time. So we can basically, so this is going to be an average. It won't be an actual rate of change. Okay, so what we're doing here is we're gonna take 2 points, okay, and then we're gonna do y2 minus y1. So we see that there is a 10 degree, let me just do this. So we see that there is a decrease of 10 degrees over about 10 minutes of time. So we're seeing a decrease of 1 degree per minute. So minus means a decrease. Okay, and we know it's minus because it's going down. Okay, but as I said, your rate of change here is not constant. So if you take it between these 2 points, it's going to be a little bit more than minus 1 degree per minute. But then if you take it here, it's going to be much less than 1 degree per minute. Okay, so that's why we say this is an average rate of change, because we're just taking approximately what would be. Okay, so what I want you guys to do as well, I want you to click on the test pilot here. And if it says plugin blocked, you're gonna manage, and then you're gonna make sure that it's not blocked. Okay, so now it's not blocked. And then you're gonna allow. And then you're gonna do
the flying controls of a new airplane are being tested.
You're gonna do this activity, okay? All right, So let me go back here. All right, so make sure you go over this activity. And this is your assignment. All right. So once you complete this assignment, you can submit it to the Dropbox by clicking on Dropbox right here. All right. If you have any questions, you know where to reach me.